this 2-kilogram mass has a weight of approximately 20 newtons. This makes sense because the force of gravity is equal to mass times acceleration due to gravity. 2 kilograms times the Earth's acceleration due to gravity, 9.8 meters per second squared, gets you 19.6 newtons. If I place this mass onto the friction sled, now the overall force due to gravity is 10.5 newtons, the weight of the sled, plus, we'll just call it 20 newtons, the weight of the mass, which is 30.5 newtons. That means now the normal force, instead of being the original 10.5 newtons, would be 30.5 newtons. So downward, that's negative, that's our force of gravity. Upward, that's positive, our normal force. This means now the tension used to pull must be greater because we have a greater mass pushing into the surface of the table. Looks like we get about 13 newtons for our force of tension required. Whereas before, the force of tension required for just the sled by itself was only about 5.5 newtons. This means our force of friction must also be 13 newtons, and because it opposes motion, it's negative. Friction increases with the force of gravity. Greater force of gravity, greater friction.